Okay, so let's find the intercepts first. X-intercept. Okay, that's when x to the power 4 minus 16 is equal to 0. You can factor that as x squared minus 4 and x squared plus 4. This is further factorable, x minus 2, x plus 2, but this is not. Okay, so from that, we get x-intercept potentially 2 or negative 2, provided that we don't have the same factor x plus 2, x minus 2 at the bottom. So let's factor the bottom. Right, so let's actually write the factor form right here. Bottom is differences of cubes, right? It's x cubed minus 2 cubed. That's x minus 2, x squared plus 2x plus 4. So note that they do, in fact, share this factor, and that's where the whole occurs instead of an x-intercept. So we actually have to omit this one. So x-intercept is just negative 2, and the y-intercept, okay, y-intercept happens when x is equal to 0, so we get negative 16 over negative 8, that's positive 2. Okay, so negative 2, 0, 2, 0 for x and y-intercept. Asymptotes. So for asymptote, first of all, the vertical asymptote. Because of the hole we got, okay, if there is a vertical asymptote, it'll come from this. Okay, x squared plus 2x plus 4. But x squared plus 2x plus 2x plus 4, this is actually a perfect square. 2x, where I can split the 4 into 1 plus 3, then we get, if you group these three, you get x plus 1 squared. So what does this tell us? This here is always positive, meaning the entire expression is always greater than or equal to 3, so it's always greater than 0. For us to have a vertical asymptote, this thing needs to equal to 0. I've just shown you that it's always bigger than or equal to 3. There's no vertical asymptote. There's no roots in this quadratic expression. It's a parabola that's lifted above the x-axis. Okay, the other one to consider is the horizontal asymptote, but note that the degree of the top is 1 higher than the degree of the bottom. Let's consider the horizontal asymptote. Now if you look at the degree, note that the degree of the top is 1 higher than the bottom. Okay, so that actually means we're not going to have a horizontal asymptote, we're going to have a slant asymptote. Okay, so let's do long division to get that. X to the power of 4 minus 16. So for long division, we need to put placeholders for degree 3, degree 2, degree 1, and then the constant. Okay, and then same thing, x cubed, degree 2, degree 1, and then the constant. So we need to put x here, right? So we get x to the power of 4, 0, 0, minus 8x. Okay, subtract, you get 8x minus 14, which means this entire expression, the f at x, can be written as x plus 8x minus 14 over x cubed minus 8, which means y is equal to x is our slant. So the only thing that we have to find is the hole, and we already identified that the hole occurs at 2. So to find the coordinates of the hole, we actually have to plug it in to this expression, where after we canceled out the x minus 2. If you plug in 2 into this original expression, we're going to get 0 over 0. Okay, so let's plug in 2 and you get 4, 4 plus 4. We're just plugging in this orange part. And 4 plus 4 plus 4. So that's 4 times by 8. And this is 4 times by 3. So you get 8 over 3. So the the coordinates of the hole is 2 and 8/3. And we're done. We have all the information.